like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us for today's presentation, MSD and Webcast, C# 2010 Soup to Nuts, Part 10, Arrays and Collections. Now it's my pleasure to introduce today's presenter, Bill Steele, Senior Developer Evangelist for Microsoft. Bill, you have the floor.
Hi, thank you, Sydney, and welcome everybody to today's webcast. We are going to be talking about C#, arrays and collections. So an array is basically the way that we organize like data within the memory of an application. And arrays actually allow us to do some pretty powerful things. They allow us to deal with a collection of objects as if it were just one object, so that we could pass around, for example, a group of customers to a portion of our application, or allow our application to take a group of customers and process them, each one individually. Now, arrays come in various different types within C#. The most basic type is a simple single-dimensional array. And that single-dimensional array allows you to store, one list or one group of simple objects. But there are more complex types of arrays, arrays where you might have multiple aspects or multiple dimensions of the data. For example, a spreadsheet in Excel has two dimensions when we talk about the rows and columns. And we can store and arrange data in multidimensional arrays within C# using some of those aspects. There are other types of arrays that we're going to be talking about as well, multidimensional and jagged arrays, which are derivatives of the two-dimensional and single-dimensional array, a little more complex. And then at the end of the session, we're going to talk about collections. And a collection is a very advanced type of array that allows you to do some really interesting things. Normally, an array is designed to contain a type of element, a single type of element, but there are types of scenarios where you might have hierarchical sets of data. And in that hierarchical data, you might have different types of data that you want to store. So a collection class is great for storing those disparate types of objects. And then using some of the things that we've already learned, like the for each statement, to iterate over that collection, to process each one of the items in it individually. And then we'll wrap up today's session by taking a look at generics and how generics can actually help us increase the performance and reliability of our applications. So starting off, let's take a look at a very, very simple mechanism, and that's the array itself. Arrays are very common throughout multiple, programming languages. Pretty much any higher level language above assembly has a concept of an array. And an array basically is a mechanism that allows you to store like types of data within a single object so that you can access all of the objects individually or as a group through the array mechanism. Now, the way we define an array in C# is actually relatively simple. We simply declare our type, and we tell it that in that particular type that we want to include the ability to have multiple elements within that particular object. And the way we do that is we simply add the open and close brackets after the type of object that we're declaring. And then we give it the name, similar to the way we do a normal C# variable declaration. When you do this, what happens is C# will allocate space based on how you've declared the object, and it'll always start with the first element at element number 0. So you might have 10 items in the array, but the first one is going to have an index value of 0, and the last one will have an index value of 9, giving you a total of 10 elements. So let's go ahead and start off by creating a very simple array and show you how we can actually store data within C# in that. Now, when I move to the next slide, as always, we're going to be going to a view sharing demo. And the view sharing demo, my screen is set to 1024 by 768. So as Sydney said earlier, you can press the F5 key to maximize to see the entire screen. And when I'm done with the view sharing demo, you can also press the F5 key again to return you back to the normal live meeting console window. And as always, there's the questions and answers panel. Feel free to ask any questions. Simply type them into the panel there. And when I come back from each one of the demo, I check that queue to make sure that, see if there's any questions in there. And if there are, I'll answer them verbally for you. Okay, so on to our first demo here. Now what I've done is I've went ahead and created a very simple application for our demos today. We have 4 demos, so I have 4 buttons. In the first one, we're just going to go ahead and implement the simple array button here. Now, in our case, what we're going to do is we're simply going to create a collection of integers and allow us to iterate over those collection of integers and display the values out. So the way I'm going to create a collection or an array of integers is I'm simply going to define that I want to use an integer, and I'm going to put the open and close bracket indicating that this is an array of integers, not just a single integer. And then I can go ahead and give it a name, and that's all I need to declare my integer array. But in our case, we actually want to fill it with something, because right now it's just an empty array with nothing in it. But generally what we want to have something, inside this. So what C# allows us to do is it allows us to initialize this array by simply including the values that we want in the array inside of a curly bracket collection here. So we'll just go ahead and type in 1, 2, 3, 5, and 7. So by having that, we have an array of 5 elements. Each one of them is an integer by itself, and they're stored in this integer array called numbers. And now that I have those values stored in that, I can now refer to this entire collection as this object numbers, or I can refer to each individual element individually by, for example, message box, show, and let's say numbers, element 0 to string. So now when I click on the simple array button, it's going to go ahead and populate the array with these 5 elements. And then we're going to display the value of the element in slot number 0, which happens to be 1 in this case. Remember, slot 0, the arrays in C# are 0-based, so they always start at 0. So the 1 would be in slot 0, and the 7 would be in slot 4 in this particular case. So if I go ahead and run this and click the arrays, you see I get the value 1 back. And if I go ahead and change that to a 4 and run it again, this time I get the value 7. So it's showing me the element number 4, which is the 5th one in the array, actually has a value of 7. We can also iterate over these by simply doing a for each loop. So for each, we learned this last week. So we go ahead and spin through that for each integer I. So for each integer in the numbers collection, which they are all integers, goes ahead and pulls out each one individually and puts it into I for each iteration of this loop. We can then go ahead and show this value. So we'll just copy this, and we'll change this value to an I. And now what it'll do is it will spin through that collection and tell us all the values in there. And in this case, I had a minor bug in here. And what happens is for our integer I was not initialized to 0 to begin with. In this case, it actually pulled out the values. So we can actually spin through this. We can also, actually we got that, yeah, there we go. We had the original value in there. We can also use a for statement, just like we did last week. So for in I equals 0. In our for loops, when we spin through these, we can say something like I is less than 0, 1, 2, 3, 5, while I is less than 5, I plus plus. So here we can spin through our loop using a standard for statement. Since we know the bounds of these, we can actually use that. But we can also use the numbers dot, and as we go through here, we can call the getLength method. And the getLength actually will return the length of this array, and as it returns the length of this array, and actually I have this set up wrong, we actually pass in the array into this method, but we can actually ask the array how many elements are in it, and we can use that to spin through that. So we have get the upper bounds, for example, into whatever array we have. We can also look at simply use the length of this, and this is the one I was actually looking for, so we do numbers get length. Length will give us the length value. This will tell us how many elements are in there. And again, if we run through this, we're starting at 0, and we'll get back all of the elements from our array. so there's various ways that we can spin through that, but all of them depend on these being integers inside here. Okay, so that's a very simple array. We can go to a more complex array, and that's where we talk about multidimensional support. So there are several different types of multidimensional arrays in C#, but the way we define them is actually relatively the same. We defined a single-dimensional array by simply specifying the type with the open and closed brackets followed by the name of the array. To do a two-dimensional array, say for example you wanted a collection of points, so x and y values, you would simply use a type with an open bracket followed by a comma and then the closed bracket. So in this case, you're indicating to C# that you have two elements inside here. In this case, they're separated by the comma. Now, you can have one or more commas inside of this to define whether it's a two-dimensional array or a multi-dimensional array. So in this case, if I have, just two commas inside the block, then I wind up with three values. Maybe that's a three-dimensional point in space, an x, y, and a z value. And you'll find that you use in C#, especially when you're dealing with graphics and complex objects, that multidimensional arrays come in very, very handy. And you can do some really interesting things with them. For example, you can store three-dimensional vectors and vertices and all kinds of things. And they can all be represented by these multidimensional arrays. Now, another type of multidimensional array is one that we call a jagged array. And the reason we would have a jagged array is because sometimes there's going to be cases where an array that you're building is not exactly a rectangle. So if you look at the two-dimensional array, you have an x and a y-axis. Think about a spreadsheet. When you're looking at Microsoft Excel, for example, in the spreadsheet, you have all of the rows and you have all of the columns. And you can actually move to any one of those, even though there is no data stored in them. And it's very inefficient to create an object that has, a million rows and a million columns if you're not actually using those. So we have this concept of a jagged array that actually allows you to have rows and columns that have varying numbers. So, for example, you might have 50 rows, but the first one might have 2 columns, the second one might have 3 columns, the fourth one might have 20 columns, and so on. And by having a mechanism, a jagged array, you have the ability to efficiently store data, even large sets of data where there's a lot of voids, without having to, consume memory to do that. The way you define a multidimensional array that's using a jagged kind of infrastructure is that you would specify the type followed by the open and close bracket, and then if there's another dimension to that, you can simply have another open and close bracket. And this would actually define basically a two-dimensional jagged array where the columns are represented by the second array and the rows are represented by the first array. And they don't have to have the same numbers in them for every record. So that's what we call a jagged array, or technically an array of arrays. And then inside those, you can actually have more complex storage mechanisms. So let's go ahead and pop back out and take a look at an example of a multidimensional array. Now, our last demo was done on a very simple collection of numbers. For our two-dimensional array, let's go ahead and build one that instead of using numbers, uses something like a string, a little bit more complex object. So just like before, we would define our string. Let's go ahead and call this our people array. And if I wanted to, I could call it done there. However, I haven't initialized it. So what we actually need to do is create a new string array. Now, in this case, what I want to do is pre-initialize it with some set data. So I'm going to go ahead and define a size to this array. In this case, it's 3 rows, 2 columns wide. And now that I have that, I've defined my array. It actually, I forgot my comma there. I defined it, so the compiler caught that for us. I said that there was 3 rows and 2 columns, but I forgot to specify over here that there were multi-dimensions. And now that I have that, I can actually go through and individually address each one of these. So, for example, I can say people 00 equals William, and people 01 equals Steele. And I could then do that for the other 3 records. record number 1 and record number 2. And something like that. So there I've initialized my array. It's a two-dimensional array, and each row has 2 columns, and the first column is the first name, and the second column is the last name in our particular case. Now, just like before where we initialized this up here in our simple array, we can also do the same thing here. But when you initialize it down here, it's going to look a little bit different. What I like to do is actually have these separated on separate lines so you can see what's going on. So we'll do the first one as William Steele. And we'll put a comma in there to indicate that we have a second element. And we'll do Amanda as well as Maylee. So now I have the definition of all of these together. And I appear to have, somewhere I've messed up. I'll see where that code looks right. Let's try that. Somewhere I messed this up, but I'm initializing it the same way. But then inside each one of these, I have my own initialization. And for the life of me, oh, you know what? I have an equal sign. I don't need the equal sign. There we go. There we go. So there I have, in this case, I've defined this string, creating a new string array. And in this case, I've populated it, so I don't need to do it this way. So you can see I have multiple ways of actually populating these initially. And now that I have that populated, I can actually spin through the collection and display these out. So for just like I did before, and I equals 0, I is less than 3, I plus plus. Now what I'm going to do is go ahead and display, basically I'll display the first names of these. I don't have to do all of them. And that's actually I equals 0. So we'll do a real simple string, S equals my first name. And then we'll do a S equals S plus people, I, comma, 0. So we're going to ask for the first name out of these. And then we can do a message box. Show S string. So what I've done here is we're just going to spin through this loop, spin through each one of these elements in this array, and just display the first name in a dialog box. So as I run this, we'll get our first name William, first name Amanda, and first name Maylee, and then the code ends. So in this case, I have 3 objects, each one with 2 elements inside it, all stored within the same array. And now I can deal with this as a single people's array, where I have all of the data stored in one object. I can pass it around to other methods if I need to. I can process it or do whatever I need to. And then, or I can address each one of them individually, like you see, with the sub-index, the index and the sub-index right on that. So, for example, if I rerun this again, only this time I look at element number 1, which is the second element, you'll see that when I run this code, we'll get the value steal for all 3 of them, since all 3 of them have the same second element defined as basically the last name. Okay, so that's a multidimensional array. Now let's take a look at a little bit more complex object, the collection. Generally, when we're dealing with code, we want to do, when we're dealing with a collection of objects in code, we want to do something a little bit more complex than just store them and retrieve them. An array is great because they're very small and efficient. They basically store everything in memory in a nice organized pattern, first in, first in, last out kind of scenario. They're organized, sequentially within memory. But a lot of times you need to access the data in ways that, in the order in which in an order in which you didn't insert it. For example, in our case, we had the array that had William, Amanda, and Maylee in 3 in that order, and those elements will always be in that order. but sometimes you might want to sort them, for example. And if we were sorting it, I would have to create a new array, and I would have to spin through the array and find, all of the aspects that, do all the business logic on that code to actually figure out the sorting routine. But it turns out within the systems namespace, there's an object called systems collections. And in system collections, we actually have an object that is called a list and an array list. And these elements, these objects actually have a lot more functionality than just a simple array. They have the ability to do things like sorting and comparing elements to each other. They also have a very unique ability that we can insert and remove elements anywhere from within the collection. So if I had the array that I used earlier with the 3 individuals in it, I couldn't remove the middle element without actually having to reshuffle or replace it with something, because that spot would still be voided in memory if I didn't do anything with it. But a collection, on the other hand, allows me to insert and remove elements anywhere from within that collection. It also allows us to do variable-sized objects. So this is the really neat thing about it. A collection has no predefined preset values. You can add any number of elements to it, and you can remove any number of elements down to 0. So let's go ahead and take a look at a collection and how we can utilize that within our code. Back over to my sharing demo. This time we'll just bring up the collections class. Now, instead of using the array that we were using earlier to store our people, I'm going to go ahead and create a new people object or person object. And this is just going to be called class person. And in our person, we're going to have a couple of properties. We're going to have a string representing the first name, and we're going to have another one, a string, representing the last name. So now I have this object called person, it's a class called person. Let's go ahead and create an instance of that in our code so we can see what that looks like. So what we'll do is we'll say wrong language. We'll say person bill, and we'll do lowercase because it's internal here, equals new person. And then we'll say bill.firstname equals William, and bill.lastname equals Steele. So now I've created this object. I can create another one. Let's do a person, call it Amanda. And again, we'll do the same thing. So Amanda.firstname equals Amanda, and Amanda.lastname equals Steele. And I'll correct the spelling up here, new. Okay, so now I have these 2 objects, and if I wanted to, I could actually create an array to hold them. And that array might be something like person array, peeps equals new. Actually, we can just do it that way. And I might define, there might be 2 elements in there, or whatever. It doesn't make any difference. We could define this however we wanted. But again, we wouldn't be able to sort this or do anything with it. We would simply be able to iterate over it like we did in the previous code. But we have this option where we can actually create a new class or actually just create a collection object. And in this case, what I want to do is I'm going to create a class that's going to hold a collection of persons. In other words, it's going to hold people. So I'm going to call this my people class. And our people class is actually going to contain, or be derived from, I should say, the built-in collections object called an array list. So the way I'm going to do this, I'm going to say it inherits, that's the colon in C#, the system.collections array list object. So my people class is now an array list, okay? Very similar to an array, but now that I have this array list, I can take advantage of some of the functionality that it gives. So let's go ahead and go up here and create our people collection. So we have our people, we'll call it peeps, equals the new people class. And now we can actually look at the peeps collection. Actually, I want it peeps as in plural. My peeps collection. And when I hit the period, we get our IntelliSense, and we can see that right away we have this add method. And not only do we have the add method, I have a whole bunch of other methods in here that allow me to do some interesting things. For example, I can remove an element. I can insert an element. I can actually, copy it, the entire collection of it. I can get a number of elements that are in there. What is the current count of that? In our case, what we're going to do is we're simply going to add Bill to this collection, and we're going to take Peeps, and we're going to add Amanda to this collection. So by adding Bill and Amanda, I've just added these two people elements to this collection, and now I can go through and spin through and actually display each one. So let's go ahead and do that. For each, in this case, person P in our Peeps collection, and we'll do a message box, show, and we'll just do peep.first name. So we'll just display the first name of everybody that's in this collection. So here I've added both Bill and Amanda to it. When we run this, I get William and Amanda as the first names that I'm reading back out. Now this is good. This is actually getting us where we want to be. And if I wanted to, I could add any other numbers. And in fact, I could even go through here and do something like get a count, find out how many elements are in there. So let's just do a message box. Oops, get my hands right back on the right keys here. Message box show peeps.count.toString. So in this case, it's actually going to show how many elements are in this collection beforehand. So there's the number of 2, William and then Amanda are the 2 that are in that. And you could go through if you wanted to and actually remove an element. So you can say remove, for example, Bill from this list. Now we added Bill to the list earlier, and now I'm removing it. And then again, we could do the same code here. Let's just copy this down to here. So we'll do that over again. So we'll get 2 the first time, so Bill and Amanda are in there. And then now we only have 1 element, and Amanda is the only one left. So you see how we refer to the object in the array by its object itself. So we remove that object from that collection. The cool thing about that is that was the first one in the element. There's no way I could do anything like that in an array. I would actually have to wipe out the array or just simply replace it with some other new value. And this actually is not very efficient from a memory standpoint. Whereas when we have the collection object, we actually wind up with a very efficient mechanism. It only has pointers in the array, and it simply removes that pointer to the object. Now, because I haven't destroyed the Bill object, it still exists in memory, but I could then destroy it if I wanted to, and it would be free to do that. So that's actually a really cool thing about a collection object. And there's a whole bunch of other elements that you can do with a collection that you can't do with an array. I'll leave that to you to explore. However, there is one major issue here. And that major issue revolves around this. What if I declared an integer? We'll call it J just to be different, and we'll make it some value, 100. And then I took my Peeps collection and I added that integer. Notice the signature for our add method is looking simply for an object itself, so system.object. In other words, this array list can actually hold any type of object. So adding our J to this collection is a perfectly valid thing to do. There's absolutely nothing wrong with adding it. In fact, an array list can hold any type of object. So here I've been adding the person type objects, and then I go through here and then I add the integer type object. Let's just move that down there, and let's run this code and see what happens. So here I have 3 elements in there. The first one is William, the second one is Amanda, and the third one, whoa, wait a minute, we just got a crash. The reason the app crashed is because our code was expecting a person object to be in this array or in this collection, and in fact it was an integer. And an integer and a person they're 2 different types of objects. They're not compatible with each other. And this presents us a problem. You'll notice that when I ran this code, it went through the code several iterations before it encountered the problem. So we did not know about this ahead of time. We didn't find this out, for example, until after our code shipped, okay? So what we needed to do is, we had to fix that and make sure that we figure out some way of ensuring that only person-type objects gets added to this Peeps collection. And you can see this is something that would be pretty easy to actually run into. So I'm going to show you now a way to solve that. Actually, I have two questions in the queue here. Let me ask them real quick. The question says, how do you define peeps? Peeps is actually, I just created an instance of the people class. So the second question in here is it faster to do a for okay, the question is about which is faster doing the iteration of checking the people's count collection, iterating it over it, or doing a people minus 1. I can't see that code all the way. Actually, the plus is actually the faster mechanism, simply because you're iterating over it. You for int people equals people's count. The people's count actually is it's actually going to be evaluated only on the first iteration of the loop. If you were doing it inside of the evaluator, it would take a lot. It would do some more processing. I only did that as a demo in our code earlier, where I did the count. You could do it either way. It's the for each loop is definitely going to be slower than an iterative using a for with an indexer, simply because the for each actually has a little bit of overhead. However, the for each can actually process multiple types of objects, whereas if you were using for example, the integer that you're using, you're only going to be able to deal with the one type of object. You'll see how actually we have a better way of dealing with this in just a second here. Okay, so the way we solved that one problem, where we actually had the wrong type of object that's stuck in our collection, for example, is to use something called a generic. A generic in C# is actually a cool concept that basically allows us to strongly type our arrays. And what I mean by strongly type, I mean that you can only allow one type of object within that array, and that's defined by the type of object that you specify. So in our example at the bottom of the screen here, we have a list, which is a generic list of integers. So inside the brackets, we have the type int, int. And that means that this list that we're creating can only contain integers. And the nice thing about that is because it's strongly typed, and what happens is Visual Studio can look at that, and the compiler can check this. As we're typing in our code, it can confirm that the only thing that we're adding to this list is the object of the type integer. And in other words, it will not allow any other types in there. And the beauty of that is because we're checking it at runtime or at compile time, we don't have to check it at runtime. There's a whole lot of other features that go on inside the .NET framework around simple objects, value types, and reference types, and passing them into method calls and things like that. That causes some interesting things to happen under the covers. There's a technique called boxing and unboxing, for example, that allows you to pass objects, value objects into, pass them into a by reference call. And what happens is this boxing and unboxing allows this object to be moved from the stack to the heap memory in a way that can be shared across these other processes. But that boxing and unboxing process is very, very compute intensive, if you will. There's a lot of instructions that go on under the covers to allow that to happen. And the only reason for doing it is because they have to do this type checking around them. Well, with a generic object, because we've already checked the type while during compile time, none of this boxing and unboxing has to occur, and that therefore makes the collection classes, generic collection classes, faster. There's a couple other mechanisms that under the covers that also make this faster, but suffice to say is it's always better to know ahead of time when your app is going to have a potential to crash, and a generic collection allows you to determine that much, much sooner and much more often than a standard collection class. So let me go ahead and go back to our original code over here. And in our original code, we're going to basically take it and convert it into a generic version of that class so that we can actually see how the generic handler deals with it. A generic list, deals with it differently than the standard collection class. So what I'm going to do is I'm just going to copy my code, and I'm going to paste it down into the generics. But instead of doing the people class, and by the way, the question earlier was how did I define the peeps collection? It's people peeps is a new people class. So I've defined this class called people, which is actually this array list, and I've just instantiated that. So that's how I define peeps. But what I'm going to do now is I'm going to go ahead and create another class down here that's going to be very similar to my people collection, but it's going to be a generic people collection. And instead of it being a derived from system.collections.arraylist, we're actually going to derive it from a class called list. And you'll notice that list, when I type it in, it has this open and close bracket at the end of it. That open and close bracket is expecting a particular type, a strongly type of object. And we're going to use the person class that we defined earlier. That's this person object right here. So now our generic list can only contain lists of a type called person. Okay, so when I go back up to my code, let's copy generic people. Let's change this to generic people. So now it's using my generic list. Notice how none of the other code changes. As a matter of fact, when I run this, when we do the generics, we get exactly the same code that we did before. Same execution. Everything works fine. But if I uncomment this code here, where we define J and I try to add it to the collection, notice how we get the red squigglies in C#. C# is indicating to us, hey, this is a generic class called generic people, and it can only accept type persons. It cannot accept the type integer that you're trying to pass into it. So you can see right away that I've already caught an error that I wasn't able to catch with before. In this case, using this code, there is no error thrown. There's no exception, no anything happening until I've shipped the product, and 6 months later somebody runs into this line of code. Where here I actually see it immediately right inside of Visual Studio before I've even had a chance to compile it. And in fact, if I try to run it, Visual Studio won't even let you run it, saying, hey, this code does not work. You need to fix this error before moving on. So in this case, I can comment that line of code out. That's the only bad line of code. And now when I run it, here we get 3 elements. It's going to crash. And in the other one, if I run it, we already know that there's only 2 elements, and that's the correct way of doing it. So the interesting thing is that we're using this generic list as opposed to this standard collection, and we're simply defining that everything else is actually the same. Now, there is one other benefit to doing generics in this case. Let me go ahead and comment that line of code out so that it doesn't break us. And that one other benefit is, earlier when we looked at the peeps collection, let's just go ahead and do it here, peeps dot. You notice that we go down through here, we have add range, binary search, and clear. These ones that have just like the moving block, those are methods. That indicates a function or a method. And those are the only type of elements that are in there. However, by using a generic, I can actually take advantage of a feature in C# called link. So if I go down here and I type same thing, peeps dot, and I scroll down through here, actually I'm not seeing it in this particular one because I forgot to add the reference to it. Using system.link, go back down to my code, peeps dot. Now as we go down through here, you'll see I have a bunch of new methods on here that have, instead of the moving arrow, moving block, they have these down arrows. And these down arrows actually indicate that instead of using a standard method, we have these optional methods available to us. And these optional methods are what they call extension methods. And they're handed to us by this technique called link. Link is language integrated queries, and what it allows me to do is it allows me to actually, and actually that one was a little different. There we go. That's why I didn't get all of them. There's all the rest of them. It allows me to actually query these. For example, I can do an order by and sort these, or I can actually select these. I could filter these down, for example. whereas with a standard collection object, I don't get all of those. So peeps dot, I only have a few of them. I can do a query as a parallel, but you notice I don't have the sorting, or I don't have those other features in there that I get with the generic collection. The generic collection allows me to deal with this data in a whole new way. Now, I'm not going to be talking too much about link in today's talk, aside from saying that a generic collection allows you to do a lot with it. Whereas this link topic really is, a whole webcast series just by itself. There's so many wonderful things that it allows you to do. But the cool thing is it allows you to query this data in new ways that we could never do before without the generic collections. There's some really, really neat things that you could do here. Here's a lookup list. You can convert them to an array if you want. So if you want to display it, you could do a to-list or to-array. You can actually join different collections together using the union command. Very, very neat kinds of features that come with link. And that's just one of the benefits. So that hopefully gives you an idea of some of the things that you can do with a collection or array objects in C#. We've seen how we can define them. We've seen how we can use them. As a matter of fact, you can see that in this case the peeps collections, either the generic or the standard one, you use them identically. However, the generic versions have a lot more power. They're a little bit more efficient. There are cases where a standard collection object might be better. Again, you want to be very careful when you're using them. They do have the potential to cause some problems like you've seen here, but they also are incredibly powerful. So let's go ahead and back over to our slide deck here. Actually, there's a great question in the queue. It says, if I change the last name of William in the collection person, how do I check to see if the object exists in the collection and update it? I normally do a link query, so somebody's already way beyond our code, but I could actually simply change the object bill. It's already in the collection. I could simply change the object. I could actually literally just within the code change the last name of the bill object, and it will change in the collection because it is the same object. So you don't have to search for it or retrieve it or anything like that. However, you can ask the collection for those. You could actually do there's several different mechanisms where you could actually choose that. You could do the link query. You could also simply go to the elements that are in there and, well, a link query is actually the easiest because it's actually going to do the same thing that I'm talking about. But you could actually go through here and do a remove on it and re-add it if you wanted to do that. But you really don't have to. If all you have to do is modify the original object, and because it's already in the collection, as long as you haven't broken that collection in any way, it'll still be in that collection. So you can, if you modify the original bill, you've added bill to the collection, you simply added a pointer to that collection. So as long as you haven't passed that off to some other out of process call, that object is always going to be the same object in the bill collection as bill in the collection. So you can change either one of them and it should be fine. So we saw today arrays and how we actually handle arrays, how we create them, very simple arrays, and we saw that you can actually have more complex arrays where you're dealing with multidimensional data, various aspects of the multidimensional data, including its simple two-dimensional all the way up to the complex jagged arrays. And then we saw the collection classes and how the collection classes can be used to store like data between the generic classes and the regular classes. We also saw how we can help improve our code, help improve performance, and we can see how how you can use the code, how you can use these collection classes to store like sets of data, and how you can query it and retrieve that. Now, my slide is a little wrong. It says next week, but technically it's not next week. We are changing our format for this webcast series starting in the next episode, and that instead of being a live webcast, we're actually going to a screencast, which will be posted on my blog as well as will be hosted on MSDN. However, I'm actually off next week, so it'll be the following week that we start that back up. We also have a couple new series coming out, and then the next webcast series that I'll be doing It's ASP.NET Soup to Nuts. And that's a 6-part series where we'll be covering the aspects of ASP. Covering the aspects of ASP.NET. And then we're going to have a very immediately following that, or immediately along with that, is going to be another webcast series called Azure Soup to Nuts, where we take the concepts that we learned in ASP.NET and we move them to the Azure cloud services. So those will be our next live webcasts. And then the screencast, so the next screencast that we're going to be talking about in this series is actually going to be dealing with how you create and manipulate strings in C#. Now, I did a lot of code in this example here where I concatenated strings together. And really concatenating strings together using the plus, the overloaded operator for strings, using the plus is actually very inefficient in C#. The reason it's inefficient is because strings are an immutable type of object. You cannot change them in C#. So whenever we're trying to take one and add another string to it, in reality it creates an entirely new string. But we have an object in a system namespace called the string builder class that actually solves that problem for us, and we'll be covering that. And oh yes, Ken's got the question about downloading the sample code. Yeah, I had an issue with my blog. We moved my blog over from one service to another, and they actually had inadvertently restored the wrong backup. And so I will have all of the demo code out there, out on my blog here shortly. We're actually in the process of recovering that. But I have all the demo code separately, so if you need it, just send me an email and I can zip it all up and send it to you. And that's actually the same question for Vincent. We'll have that. Just check on my blog. In fact, here's the slide. Here's the slide for my contact information. Send me an email, and I'll actually have it out on my blog here in the next day or two. And feel free to send me an email at wsteele@microsoft.com. Follow me on Twitter at WJSteele, and here's my blog address, blogs.msdn.com/wsteele. And I promise we'll have that back up to date. Cool. Now I'm going to go ahead and turn it back over to Sydney where she can get you into the survey. Please fill out the survey and, let us know how we're doing. Let us know what kinds of additional webcasts you'd like us to see. And if you'd like to, get these back out on the standard live meeting style format, let us know that too. Sydney?
Thank you. I'd like to remind everyone that you can print a PDF of the slides by clicking Control-P. You can either print or save a copy of those slides locally for your convenience. You shall be seeing a survey now in your site area. If you could take a moment to fill it out before you log off, we do appreciate any feedback you leave for us. All you need to do is follow one of the 3 links provided to complete the evaluation. And I'd like to extend a special thanks to Bill Still for today's presentation. Thank you all for joining us. You may now disconnect from the audio portion of today's conference.